warm welcome to all the viewers. Today's session of tourism and hospitality research is going to be a special session. As you can see, the word highlighted in yellow, bootstrapping. Quite a fascinating word. But what is it actually? It is a procedure which is meant for analyzing non-normal data in AMOS. The data which does not fulfill the requirements for conducting parametric tests is non-normal in nature can be executed through the bootstrapping procedure. What is this bootstrapping? For young researchers, it will be quite useful to know that there is something magical out there which is known as bootstrapping. When you are conducting multivariate normality assessment in AMOS and your data exhibits non-normal nature and you are using maximum likelihood estimator MLE, which assumes that the data needs to be normal in order to be assessed, then only you will get valid and meaningful results. But you found out through the normality tests that the data is not normal. In that case, are you going to stop your research right away? Or you are going to go back to the field and conduct the survey again to collect new data? Yes, these are the questions which I am going to answer in this video. You don't need to worry about that because there is a magical concept which is known as bootstrapping. So let us start. What is bootstrapping? It is a statistical method that involves resampling a single data set to create confidence intervals, lower limits and upper limits, and conduct hypothesis testing. It takes additional samples repeatedly from the initial sample to provide estimates of its variability. That means in case you have collected a data on 200 people, your sample size was 200 and you found out that your data does not meet the multivariate normality assumption which is required to be present in case you are doing structural equation modeling in AMOS. Then when you apply bootstrapping procedure, it will resample several data from the simple single data which you have got. So you can do a bootstrapping and analyze the data with 2000 samples, 5000 samples, 10,000 samples as recommended by different researchers. So it is going to create new samples out of your existing data. How does this bootstrapping work actually? What is the principle behind it? Does bootstrapping work on the principle of central limit theorem? Bootstrapping uses resampling with replacement to create multiple data sets, and the distribution of statistics calculated from these data sets often approximates a normal distribution, a concept which is well explained by the central limit theorem. What is central limit theorem? I have explained it in my video on normality. It states that the distribution of sample means will be approximately normal for large sample sizes regardless of the original population's distribution. Bootstrapping leverages this principle by simulating many samples from the original data to estimate the sampling distribution of a statistic. Here are some useful resources which you can refer to and learn further about the bootstrapping method. Now let us go to the AMOS and check it out how to do bootstrapping. So here we are in our AMOS model. So once you have done the measurement model assessment, you have co-varied all the variables, independent and dependent variables, whatever are there in a study, you have co-varied them, and then you are testing the model fit, that is known as measurement model assessment. After measurement model assessment, you have to check for multivariate normality so that you can go ahead with the structural model assessment. That is how to explain the hypothesis, how to test the structural relationships between your independent and dependent variables of the study. For now, the purpose is to see that how bootstrapping might help you out. So this is the model which we have built. I'll just click on calculate estimates. Now, once I calculate estimates, I go to view text, and here are my results. Now you see assessment of normality. The CR, critical ratio, or the Mardia's coefficient of multivariate kurtosis, 6.798. Many researchers say that if it is below 8, it is acceptable. Several others say that it has to be below 5, as stated by Bentler's reference 2005. I explained it very well in my last video on assessment of multivariate normality in AMOS. Now, in case you have this value 6.798 and you feel that this value has to be below 5, then only I can justify that my data exhibits multivariate normality. Although in this case 6.798, we can directly go ahead and say yes, our data is approximately multivariate normal because the critical ratio, this CR, is less than 8. So I can directly go to my analysis. But still, I'll show you if this value is too high. Say for an instance, this value is around 19, 20, 30, something like that. Then what you need to do? First, you go to the Mahalanobis distance and found out those values which are quite unusual and higher than rest of the values, and the P1, P2 significance level is lesser than 0.001. In this case, we don't see any of the values lesser than 0.001. That is the significance level. So in case any of the values is lesser than 0.001, we will say that it could be a potential significant outlier, and we need to remove that respondent, that case number, that sample from the study. So what next? In case this resolves the issue on multivariate normality, then it's okay. Otherwise, you can go for bootstrapping. How to do that bootstrapping? Let us see now. So I'll close this window. I'll go back to view, analysis properties, bootstrap. You see here bootstrap. And in bootstrap, I'll click on perform bootstrap. 200 by default is quite a less number. I'll change it to 5,000, at least 5,000. And it's often seen that 5,000 or 10,000 bootstrap samples will give you quite a stable result. Then bias corrected confidence intervals, make it 95. By default it is 90, but we are doing a study at 95% confidence interval. That's why I clicked on bias corrected confidence intervals and made the value 95. Now bootstrap ML. ML stands for maximum likelihood, and then Bolenstein bootstrap. So I'll click on Bolenstein bootstrap. Now one thing to be taken care over here is that in case I just want to see the distribution of the bootstrap samples and test the null hypothesis for my model fit. Null hypothesis in this case is that my model is correct. So then I don't need to click on bias corrected confidence intervals. This I need to check when I want to know the individual indicators, estimates, and how do they contribute to a particular latent variable. Now, for now, I just click on Bolenstein bootstrap. I uncheck on bias corrected confidence interval. So again, I go back here and calculate estimates. Now see, the model run well. The chi-square which we got is 358.8. Now chi-square is 358.8. We are assuming for this video that this model has passed the measurement model assessment and all the model fit indices are quite okay. And then we have moved to the multivariate normality assessment for this model. So chi-square is 358.8. Now we'll click on view text, and again I go to the view text tab, and now I have this bootstrap distribution. Now you see here 358 is not lying anywhere in this bootstrap distribution. That means my chi-square value is out of the scope of this distribution. So that means my model might not be correct. So I'll go to Bollenstein bootstrap. Now you see here the model fit better in 5000 bootstrap samples. It fit about equally well in 0 bootstrap samples. That means there's no effect. Testing the null hypothesis that the model is correct, Bollenstein bootstrap P is 0.000. So this has to be insignificant. That means greater than 0.05 in order to accept the null hypothesis. In this case, I will not be able to accept the null hypothesis because the p-value is lesser than 0.05. Now, this means that my model is not correct. So that means, should I stop with the analysis? What should I do? I can state that yes, in this case the critical ratio was 6.798. In case it was higher than that, then also in that case I can go further with the bootstrap technique. How to do that? Let us see that. So now I'll go back again to the view analysis properties, and under bootstrap I'll click on bias corrected confidence intervals and uncheck Bollenstein bootstrap, and then again run the model, calculate estimates, and now I'll again check what results are given by AMOS, view text, and these are my results. So now under scalars I had to click standardized regression weights, and then I have the bootstrap confidence bias corrected percentile method standardized regression weights. Now it's quite convenient to see that all the indicators of different latent variables, fq1 to fq4 belong to fq latent variable, ca1 to ca4 belong to ca, sq1 sq4 belong to sq, vm1 to vm4 belong to vm latent variable, and bi1 to bi4 belong to bi latent variable. So I have all the indicators of my model, and the standardized regression weights or factor loadings, that is what we call them. If we are doing a CFA, confirmatory factor analysis, we call the standardized regression weights as factor loadings. Now I need to check this lower limit and upper limit, which we saw in the slide also, that bootstrap generates the lower limit and the upper limit. Now we have to see the lower limit and the upper limit. If 0 falls within the lower limit and the upper limit, then we will say that our result is insignificant. But if the 0 does not fall within this lower and upper limit, then we'll say that this is a significant contributor to the latent variable. This indicator fq1 is a significant contributor to the latent variable. Now in this case you see, yes, the lower limit is 0.624, upper is 0.810. That means 0 does not lie within the lower limit and upper limit, and the p-value is 0.000, lesser than 0.05. So it is a significant contributor to the latent variable. We see all the indicators are quite significant contributors, right? So in this case, all the variables are quite significantly contributing to the latent variables. All the values are below 0.05, and the bootstrap lower limits and upper limits, there is no 0 falling in between. So I can produce these standardized regression weights in my results and say that I can move ahead because The bootstrap bias corrected percentile method reveals that all the indicators contribute significantly to the latent variables, and then I can go ahead. And one thing important to note over here is that bootstrapping does not assume normality of data. So when you are applying the bootstrapping technique, you don't have to worry about whether your data is normal or non-normal, and you can go ahead with the analysis. Whether you want to do a measurement model assessment or you want to conduct a structural model assessment, you can use this bootstrapping technique. Do share it with your friends and faculty colleagues. Keep learning, keep watching for more. Thanks a lot.